Hey Christian, I know you're touring the school for sports, so I'll show you around and show you the baseball field.
Great, where do we begin?
Whoa, I wonder what the momentum of that ball is.
Well, why don't we check that out and see?
Okay, Christian, what is momentum exactly?
Momentum is mass times velocity of an object.
So this means we need to know how far and how fast something moves and the mass of it.
That's correct. So if I had a timer and we stopped it when it hit the plate after I hit the ball and it was 8 seconds and traveled for the total of 24 meters, the velocity would be 3 and the mass of the ball is around 10 kilograms. So after multiplying them, the momentum of the ball would be around 30.
Hey, you guys already told me.
So Christian, does this mean if we use the lighter ball, the momentum wouldn't be the same?
That's right, because if either mass or velocity changes, the momentum is not the same. Think about the momentum of a large moving boat at the same speed as a jet ski, that they don't have the same momentum, right?
You're right, so maybe we should try hitting the ball and see if it's true.
Okay, let's do it.
Ball number 1. And ball number 2, you can see the ball with less mass went further.
Gabby, why doesn't the ball have momentum when it's just sitting here?
Well, this is a conservation of momentum. There are only internal forces acting upon the ball, and in order for something to have momentum, there must be an external force applied. But remember when you hit the ball with the bat?
Yeah, so let me guess. Since there was an external force, me hitting the ball with the bat, the ball therefore had momentum.
Yes, exactly.
What is an example of when momentum is conserved?
Remember when we were talking about systems in class the other day?
Yeah, so I'm guessing that has to do with it.
Yeah, so if we had 2 baseballs and they were both at the same mass, which means they would move at the same momentum, and they were both in the system, the momentum would be conserved.
Oh, so if one ball was at rest and the other ball came and hit it, the momentum would be conserved because they're both in the system.
Yeah, correct. Christian, can you give me an example of when momentum isn't conserved?
I sure can. This means the system is smaller, so in case only one ball will be in the system.
Okay, so this means what?
This means if the ball is in the system is at rest and the other ball out of the system hits it, an external force is applied, and therefore, since the moving ball hits the still ball, it looks like the momentum is conserved, but it is not because there is only one ball part of the system.
Christian, what is the difference between an elastic and an inelastic collision? I always forget.
Well, an example of an elastic collision would be when one rolling baseball hits another baseball at rest, and they continue moving together like they're stuck to one another.
Oh, so this means the mass becomes twice as much and the velocity is half. Now there's double the mass because the balls are moving together and the velocity stays constant, which makes it half as much as the new mass. An example of an elastic collision is when one rolling baseball hits another baseball at rest and the rolling baseball transfers its momentum to the baseball at rest. So the result would be the rolling baseball comes to a rest and the baseball at rest is now rolling.